Hi friends, today we will see the concept of finite element method. Actually, this finite element method is also termed as a finite element analysis. Uh, this point is very important. Those who are interested to work as a design engineer, because in mechanical engineering when you design any component you have to test the design of that component, and FEM is a better option for designing the validity of that component. For checking the validity of that component, FEM is the best option. Now what is the analysis? First of all, let us know this. Analysis means effect of internal and external forces on the object that we have to determine. So determination of internal and external forces on the object, that can be called as an analysis. Now in FEM we are going to determine the stress, strain, deflection or different degrees of freedom of that component, and that process can be called as an analysis. Now there are different finite element analysis softwares. These are available in market. Those we will discuss one by one afterwards. What is the meaning of word finite? Its dictionary meaning is limited. Finite means limited, and element is a small piece of that component. So finite means limited and element means a small piece of that component, and analysis that I told you now. So combination of these three words that becomes the dictionary meaning of finite element analysis. So we have to look towards the exact application of finite element method, and we have to select a proper software for finite element analysis. So for doing this we must know the concept of finite element method. So therefore we are discussing now the concept. Now what is done in FEM? See, in FEM we are interested to divide the components into number of small pieces, and each piece is called as an element. You can see this diagram here. Each piece is called as an element. Now this is just a piece of a plate, you can see here. So this is a plate, and it's a 1/4 part is taken for analysis purpose. Now it is divided by using a triangular shape. So this is a triangular shape, this is a triangular shape, here it is a triangular shape, here it is a triangular shape. But the whole component is like this. And now here around the curved surface also triangles are used to divide the structure. So here triangular element is used to divide this structure. So as I am repeating, element is a small piece, but you can observe here, suppose this is the element 1 and this is element 2, and both are connected to each other by a point. I will call it as a common point. This point is called as a node. So again I am repeating, a common point in between two adjacent elements is called as a node. Simply application of node, why node should be there, that we will understand afterwards, but node must be there in order to get the values of deflections, in order to get the values of temperatures and many more. So here you can observe these points. These points are called as nodes, and this space you can call it as a element. Now why elements are important, or why elements and nodes are required in FEM? The very first thing is that without having nodes and elements you cannot get any kind of answer in finite element analysis. Suppose you want to do the analysis of cantilever beam, you must have elements and nodes in that cantilever beam. So division of that component is must. Without that you cannot go ahead for getting the different answers. Now you can see here, by using triangular shape this curve is tried to discretize. So meaning of discretize means division. So in finite element method there is one concept, discretization. Discretization is process of dividing number of elements, process of dividing components into number of elements. Now here you can see this component is divided into number of elements, that is called as simply discretization. But discretization is also called as a meshing. Again I am repeating, discretization is also called as a meshing. So meshing, this particular word is used in softwares. If you go to the ANSYS software there is a word meshing. Even you go to the LS Dyna, you go to the Hypermesh software, there is a separate word used, menu, you can call it as a menu, named as meshing. So discretization word is used in theory and meshing, this word is used in different APM softwares. Now, you can call this meshing, somewhere this meshing is also termed as discretization, discretization is also termed as a meshing. So there should not be a confusion of this. Representation of the object in the form of elements, that is called as a meshing. Representation of object in the form of elements, that is called as a meshing. Now this diagram, particular diagram, it shows nodes and elements, and almost there are 49 elements present in this meshing. 49 elements present in the meshing and corresponding elements. So in APM, very first step is to divide the structure into number of elements. So there are actually 3 steps that we will discuss afterwards. First one is pre-processing, then solution, and then post-processing. These are the 3 basic steps. So same thing is written here in a slide. Now there are the applications, worldwide applications of APM, that also we will discuss one by one. What is advantage of finite element method? Before that I will tell you the root of APM. The root of APM is that it is a numerical method. So some students have confusion that APM, whether it is a numerical method or analytical method. Yes, it is a numerical method. So numerical methods we are knowing very well, like Newton-Raphson's method, Runge-Kutta method. So these are iterative methods are there. So these are called as numerical methods, and APM is based on such numerical methods. So you are knowing that numerical methods are not accurate, they are giving approximate answers. Numerical methods are giving approximate answer, these are not giving correct answers. So analytical method that gives accurate answer, but numerical methods that gives approximate answer. So APM is numerical method. So just remember this. There is a difference in between analytical method and numerical method. So do not forget this, that APM is a numerical method. Now, whenever you go to the software, there are different types of numerical methods are available in softwares. So you have to choose a proper method which gives answer near to accuracy. So depending on the type of numerical method, you will get the precision or precise answer. So that you have to select. Obviously, there are different criteria for improving the accuracy of element. That also we are going to learn in this chapter. So in the concept, there is a very important thing. You have to improve the accuracy of finite element analysis. So if you go to the ANSYS software, you must focus on how I can improve the accuracy of analysis. So for improving the analysis accuracy of the analysis, there are different criteria. So you can see here, just example I will discuss here. For improving the accuracy of the analysis, suppose here size of element is small and at this age a size of element is large. So because of this, what happens, accuracy of the results will be more at this location, accuracy of the result will not be good in this region. So as you reduce the size of element, you can see here size of the element is reduced. So as you go on reducing the size of element, uh, the accuracy of the analysis will be good. Accuracy of the analysis will be good. So this is just one criteria. Actually different criteria for improving the analysis accuracy, but in software there is an option you can reduce the size of analysis. But when you go for the hand calculations in finite element method, by hand you want to calculate the stress strain deflection values. So there you have to choose different types of numerical methods. You have to choose the different types of polynomials, zero order polynomials, higher order polynomials, and depending on that the accuracy of analysis will be there. So this is what the concept of finite element method. If you would like to know the applications of FEM, there are a lot of videos available on youtube.com. You can search there the applications of a finite element method. Uh, so one application in mechanical engineering, automobile engineering is very heavy. Automobile engineering has a lot of scope to implement finite element method. Every component of automobile will give you interesting finite element analysis. For example, analysis of shock absorber, analysis of camshaft, and then analysis of engine block, analysis of piston cylinder assembly, then steering gear mechanism. So there are a lot of components present in automobile, and there is a huge scope for analysis. So this is about mechanical engineering. But if you go beyond this, civil engineering also implements finite element method. Electrical engineering also implements finite element method. Biomedical applications, even though you can go for the analysis of a tooth, human tooth can be analyzed by using finite element method. So these kinds of applications are available. You can implement FEM everywhere nowadays because of advanced softwares are available in FEM. So just I will put a list of FEM software before you. So first FEM software nowadays used worldwide, that is the ANSYS software, and it is called as a system analysis. It's a long form, it's a system analysis. Analysis of the system, that is what ANSYS is termed. Then LS Dyna, this is the one software. Hypermesh is specially used for meshing the complicated components. I am repeating, hypermesh is specially used for repeating the for meshing the complicated geometries. Then Adams is one software that Adams is specially used for analyzing components of automobile. So automobile, for any component of automobile, for example wheel rim is there, steering gear mechanism is there, different kinds of linkages, gearboxes, that can be simply analyzed in in Adams software. This is one software. Even though non-CAE softwares like CATIA, SolidWorks, Solid Edge, these softwares has a module of finite element method, but there you can do only a static type of analysis. In CAD softwares, you can do just static type of analysis, but CAE software, some softwares are good modelers and some softwares are good solvers. So that also we will see ahead in the next lecture. But apart from this, there are many softwares. One software, the name is Abacus. It is mostly used in Roman countries. Abacus software. It is similar to ANSYS software. It has same features as that of ANSYS software. All the finite element results you can get in this Abacus software. So I just recommend to use the ANSYS software as it is good and simple. Nowadays it's a GUI, that is a guide user interface. This is also improved, and you can easily understand that software. So just I have tried to explain the concept of FEM in short period of time. Other things that we will discuss in the next lecture.